Okay, number 19 is an exponential equation, and they want to know what x is. So what I'm going to do over here is I'm going to try to write the same base. So I see 3 to the x plus 5 equals, well, 27 is actually 3 cubed. So it's going to be 3 to the minus 3. What do I now know? I know x plus 5 has to be equal to minus 3. What's x going to be equal to? Minus 8. How did I do that? I subtracted 5 from both sides. Do I see that answer? I do. It's right here. Go on to the next question. Now, I realize some students are looking and saying, oh, I need a calculator to do that. This is in the notes, by the way. These are problems that are given to you before you take the exams. And I realize for some students they may not be doing the what we're asking you to do. And it really requires a tremendous effort on your part of being able to look back over problems that we provide to you to do. But this is a problem directly from the notes, by the way. The first thing I would do, I notice they're mixing the index, and I want to get it in the same index. So I'm going to write this down for you. So it's 2 to the 1/2, and the next guy is going to be 3 to the 1/3, and it's going to be 6 to the 1/6. I'm going to get them all in the same index, and the common denominator is actually 6. So it's going to be 2, well, it's going to be 3/6, because 3/6 is 1/2. What's this one going to be? 3, well, if I get a 6, it's going to be 2/6, because 2/6 is 1/3. Then what do you have here? 6 to the 1/6. What does this give me? Well, it looks like 8 to the 1/6. All right, and how did I do that? 2 cubed is 8. What do you get over here? 9 to the 1/6. And why is that? 3 squared is 9. What do you get over here? 6 to the 1/6. So what's the smallest guy? The smallest guy, looking at them, well, looking at 6 right over here. This is the small guy. Let me write that down. They said order it. So the smallest one is 6, the 6th root of 6. What's the next smallest one? Well, it's this guy over here, which can be the square root of 2. What's the largest number there? Well, the only one number left. That's going to be the cube root of 3. All right, let's go to the next question. Oh, by the way, you may be questioning why I put a 2 there. I did it in the notes. I'm certainly going to do it here for you. It's just the square root. Let's put the next one down and, kind of looking at it, for what positive values of x does h of x equal 3? I don't know. Let's write this down. So 3 equals log base 2 x squared plus 2. Well, I'm going to rewrite the log as an exponential. That's going to be 2 to the 3rd power is equal to x squared plus 2. 2 cubed is 8, because 2 times 2 is 4, 8. Then you get x squared plus 2. Subtract 2 from both sides, you get 6 equals x squared. What's x going to be equal to? Plus or minus the square root of 6. Now, by the way, they said for what positive value, so x has to be the square root of 6. Let's look in the key. I'm seeing that. That's letter D. All right, let's move on. We're going to move on to 22. What's 22? It's a more difficult question. There's no doubt about it. But the first thing says rewrite it as a single fraction. So what I want to do is I'm going to use the space to do it. And I see x squared minus 2, x minus 1, minus, well, it's going to be 2 times x minus 1 over x minus 1. All right? And I want to do that now. I'm looking at it. X minus 1. You're going to get on top, you can get x squared minus 2 minus 2x plus 2. All right? So I think I know what the fraction is now. What is going to be x squared? The 2 disappears. You get minus 2x over x minus 1. All right, let me put out what I just did over there. I have a single fraction now. So this part's done. Let's go to the next part. Perform the long division now. So let me write that down for you. The long division, it's x minus 1. I'm going to be dividing that into x squared minus 2x. And let's do it one term at a time, by the way. I'm going to say x first, because x times x is x squared. Then you get minus x. I subtract. I get minus x. Well, I got to keep repeating, don't I? Minus 1. That would give you minus x plus 1. The remainder is minus 1. So if I did the long division, what I found x minus 1 minus 1 over x minus 1. There's my long divisions done. All right? So I did both. Okay, next thing, what is or are the y-intercepts? Well, I could look at it, I know it's 0, 0, but I want to go through the verification of that for you. So I can put 0, 0 down. I'm looking at the picture, by the way. But how would I do that? Just look at the fraction and set the x equal to 0. So by the way, this is y equals. So what do you get when you set y to x to be 0? You get 0 because the top is 0, the bottom is -1. That works pretty good. All right, what are the x-intercepts? Well, it looks pretty easy. I'll write this down for you. It's when the top, x squared minus 2x equals 0. Well, factor it. You get x and x minus 2. So I think I know what they are now. What are they going to be? 0, 0. That's when the y becomes 0. And the other one is at 2, so 2, 0. I want to look at the picture and just verify that, and I do see that, by the way. Okay, next up, what's the vertical asymptote? Well, I'm looking at the picture, but I'm going to write down first. What am I basically looking at? The denominator, which is x minus 1, so the vertical asymptote would be x equals 1. Now, granted, they're not asking me to verify that. I'm looking at a picture. I'm seeing that right over here, by the way. So I'm not going to put limits down. I do see it. What's up next? What's the equation of the slant asymptote? Well, that's going to be y equals, you just did the long division, x minus 1. I do want to look at the picture, by the way, and notice the picture also. I see that asymptote, and that asymptote clearly is x minus 1. What's the domain of it? The domain is all real numbers. However, x cannot be equal to 1. All right, you can look at the picture and see that. You can also look at the function and see that. What's the range? My suggestion is look at the picture. And I hope you realize these things are going on forever. So the range of this thing is all real numbers. All the real numbers. Let's go to the next question. And looking at it, they want to know what integers is this number between. And kind of looking at it, I'm going to say log base 10 of this 1732 is between two other logs. So I'm going to say 1700, log base 10 of 10 cubed. And why is that? 10 cubed is 1,000. What's the other number going to be? Log base 10 of 10 to the 4. So what number is this? This is 3. What number is this? 4. So this thing here is between 3 and 4, and that's choice B. All right? That's choice B. Let's keep going. This one is, find the domain of it. Couldn't be easier. It's x plus 3. Must be greater than 0. This is the domain, by the way. What's the domain of it going to be? X will be greater than minus 3. So I'll write this on the side for you. The domain starts at minus 3, and it goes off to infinity. I'll put a box on that, indicating that's done. They said x-intercept. What's an intercept? When the function becomes 0, let me do that for you. 0 equals the natural log of x plus 3. I'm going to read it as an exponential, which is e to the 0 is x plus 3. And then e to 0 is 1. You get x plus 3. So what's x going to be? X will equal minus 2. So the x-intercept, again, we're answering one question at a time as I'm reading it. Fairly simple. It's going to be minus 2, comma, 0. So we got the x-intercepts down, domain down. Oh, the vertical asymptote. What's the vertical asymptote going to be? Well, it's going to be x equals minus 3. I got that one done too. All right? What else do? I guess they want me to just graph it now. I think I can do that. My graphs aren't great, but they're good enough. I'm going to put the line down, the asymptote. That's going to be x equals minus 3. I'm going to put the x-intercept down, which is minus 2. So again, I got this down, and the general shape of a log looks sort of like this over here. Okay, we're done with that. It's 24. Let's go to 25. 25 is an equation to solve. So what do I see over here? I see the natural log. This is sum, by the way, so I'm going to make it a product. Equals the natural log of x. What do I know about this over here? That if this is true, this must be true. Whoops, I made a mistake there. What do you get there? You get x squared. Let's see, minus 2 plus 1 is minus x. Minus 2 equals x. X squared, I'm going to take x from both sides, it's quadratic. This is 2x minus 2 equals 0. I can't factor that using finger numbers, quadratic formula. That's a 2. Let's take a look at that. Let's see, 2 plus or minus. Whoops, sorry about that. Try to interpret my writing, by the way, and it does that sometimes. Let me erase this and try again. So x equals 2 plus or minus the square root. Well, it's going to be 4 minus, let's see, 4 times a, which is 1, times c, which is minus 2. So it's going to be, let's see, 8. All right, I got this done. Let's keep going. What do you get over here? 2 plus or minus the root of 12 over 2. I'm going to write over here now. It's going to be 2 plus or minus. And in 12 is 4, so it's going to be 2 root 3s. This is 2. This is going to be x equals 2, not 2, I'm dividing by 2, right? 2 goes into 2 one time, plus or minus the root of 3. So we have 2 answers. Let's write them down. 1 plus root 3, and the other answer is x equals 1 minus root 3. Now it's understandable to say you got 2 answers. In fact, you don't have 2 answers. And the reason for that, this is less than 0, and you can't put a number in there that's less than 0 in a real number system. So this is my only solution to that problem over there. That's the one that's greater than 0. So x equals 1 plus root 3. All right, let's see how we're doing. 26. I got to put this one down over here. And I'm going to say, just looking at these over here, these are growth problems over here. So these are really the 3 candidates I'm looking at. And when I'm looking at this over here, I'm looking at the asymptotic behavior of it now. And the asymptote is actually y equals 3. There's only one of these that would produce that, and it's this one over here. All right? Now, if you want to check it out, you can check the y-intercept by setting x to 0. So if you set x to 0, what's g of 0? That would be 1 plus 3, which is 4, which is right over here. And this is clearly a decay problem. What I mean by that, it's going down. And by the way, it's asymptotic with the line y equals 3. I think that's it for the exam, by the way. And we're done. Thank you.